Hey guys, we are on Unit 9 today, and we're going to do day 1, and we're going to talk about how to find area and circumference. Okay, so in our warm-up, we have a parallelogram called ABCD. Okay, and is adjacent, which means next to rhombus DEFG. Okay, as shown to the right. And they're telling us that the measure of angle B is 118. And angle AHC, A to H to C. This one right here is 138. Okay. They want you to determine and state the measure of angle GFH. So G to F to H. So this angle down here, put a little tiny question mark in there. That's the angle that we have to get to. Okay. And so let's go back to the parallelogram. I traced it in blue, and we know that opposite angles in a parallelogram are equal. And so over here, since angle B is 118, angle D will be 118. Okay. We also know that consecutive angles in a parallelogram have to add up to equal 180 degrees. And so angle A must be 62, so that the 62 and the 118 will add up to equal 180 degrees. Okay. We know that the full angle over here at C is also 62 degrees. Okay. But we just don't know quite how to split it though with that line there that splits the angle. Okay. Let's go ahead and use the 138, which is our second clue, right? We know vertical angles are congruent, and so that 138 can go down here. Okay. And let's go ahead and talk about linear pairs because we have a couple of them here. So if I look at that red line and that separator, the angle on the other side of the 138 has to add up to 180 with 138 to make a linear pair. And so I could go ahead and put a 42 right here. Okay, and therefore I can put a 42 as its vertical angle, and I'm getting closer to the angle that we're looking for in there with the question mark in it. Okay, let's still talk about linear pairs because we have another one over here with the 118 and the angle next to it. And that angle is going to have to go ahead and be 62 because 118 and 62 have to add up to 180 because they're a linear pair. Okay. What we found out now is that 62 is an angle of the rhombus, and that angles in a rhombus are, the consecutive ones are supplementary. They have to add up to equal 180, just like they do in a parallelogram, since a rhombus is a parallelogram. And so I can tell you that angle E has to be 118. Okay? And therefore, opposite angles in a rhombus are also equal, just like they are in a parallelogram, because a rhombus is a parallelogram. That this angle over here has to be 118. And now what I'm going to do is I'm going to take that little tiny triangle that I have right here. Okay, and inside that triangle, and I can go ahead and redraw it just so you guys can see it a little bit bigger, but if I blow it up a little bit, this is the angle with the question mark in it that we're looking for. We already knew that this was 42 and that this was 118, and so now I can go ahead and use 180 degrees, take away 118, take away 42, and I am going to be left with 20 degrees for the measure of angle GFH, which is what I had to go and find. All right, so this angle right here is no longer unknown, it's 20 degrees, and there's my answer. All right, very good. All right, so let's take a look, guys, at some area formulas. Cool thing is most of these formulas are on your reference sheet, which I'll be giving you. And so you'll not have to memorize them, except for this last one called trapezoid. Okay. So area is the amount of space inside a two-dimensional shape. Two-dimensional shapes, remember, guys, are flat. Okay. They are not three-dimensional. Okay. They're two-dimensional, so they're flat. All right. So they only have two dimensions. They have like a length and a width, or a length and a height, or a base and a height. All right. But they only have two. They don't have all three. They don't have length, width, and height. Okay. So their formulas won't have three variables in it. They'll only have two. All right. So a triangle is 1/2 base times height. All right. So if we have a triangle drawn here, we can call this dimension its base, and then we can call this dimension here its height. Remember, base and height has to be perpendicular to the base. So that's why if one is horizontal, the other one has to be vertical, so they make a right angle so that they're perpendicular. Okay, so whatever the red and green dimensions are there, you take 1/2 times the green length times the red length. Okay, for a rectangle, okay, rectangle would be the base, which let's say that's the base, times the height. Okay, and again, the base and the height, those two red and green lines have to be perpendicular to each other in order to be considered a base and a height. Okay, for a circle, its area is equal to pi r squared. Okay, your radius goes from the center to the edge of the circle, and circles have infinitely many radii in them. All right, but they all measure the same. Okay, whatever one radius is of a circle, all the radii measure the same. Okay, and then we have a trapezoid. Okay, and a trapezoid maybe looks something like this. Okay. And because their bases are different lengths, this is one of their bases, and this is another one of their bases. Because they're different lengths, what we have to do to them is average them. So that's the average of the bases. And then you multiply it by a height, okay? And height has to go straight up and down, okay, and be perpendicular to those bases. All right, and those are our formulas that we'll be using, okay? All right, perimeter, guys, is different than area, okay? Perimeter is the distance around a figure. All right, to find perimeter, all we have to do is add all the sides of the figure together. All right, so if it has a 4-sided figure, make sure you add all 4. If it's 3-sided figure, add all 3. If it's a 6-sided figure, add all 6. Okay, circumference is extremely similar to circumference is extremely similar to perimeter. Circumference is the distance around a different shape that doesn't have any sides, and so that's why they changed their name. Circumference is the distance around a circle, where perimeter is the distance around a figure that has actual sides. Circles don't have any sides. That's why they changed the name of it. Okay, and it has a little bit of a different formula since it doesn't have any sides to add together. It's called pi times d is your circumference formula. Okay, it can also be known as circumference equals 2 pi r. And why this formula works, because 2 r's or 2 radii is the same as a d, which is a diameter. Okay, so d is the diameter. All right, either formula will work though. All right, so let's try some examples so we can see if we can put this into play. So in number 1, it says Mr. Gonzalez owns a triangular plot of land called BCD. All right, so let's go ahead and see if we can find. All right, so he owns this, it looks like, BCD. Okay, with DB equaling 25 yards and BC equaling 16 yards. He wishes to purchase the adjacent plot of land in the shape of right triangle ABD. So he wants to purchase this piece here. Okay. As shown in the accompanied diagram with AD equaling 15 yards. If the purchase is made, what will be the total number of square yards in the area of his plot of land called triangle ADC? So notice, guys, we're finding the area of a triangle, all right? ACD. So he wants to own this entire picture. All right. So we have to find the area, how much space is inside this blue triangle. So we're going to go ahead and say area of a triangle is equal to 1/2 base times height. All right. And so what we can realize is that we can use this here as our base, and we can use this here as our height because you can see the right angle, they're perpendicular. Okay. So we're going to use AC as our base, and we'll use AD as our height. So the cool thing is we already know what the height is. We're going to go ahead and replace this H with a 15. Okay. We're going to go ahead and keep this 1/2 because it's part of the formula. It has to stay. But right in between, we don't have a base. And you guys can see that part of it's 16, but we don't have the whole length of AC. So what you guys have to use as your good detective skills here is that we have this triangle, this right triangle right here, okay, that has two sides known, but a third side not known. And we know, should know by now, that we're going to go ahead and use a squared, oops, plus b squared equals c squared. Okay, we have to realize that 25 is our hypotenuse, and so 25 in that yellow triangle has to go in for C. Okay, 15 can either go in for A or B, it doesn't matter, and we're going to solve for the missing side. All right, 15 squared is 225 plus B squared equals 25 squared, which is 625. If we go ahead and subtract 225, we're going to find out that B squared equals 400. And when we take the square root, it's perfect, and b is going to come out to equal 20. And so this remaining side of our yellow triangle is 20, and therefore now we can go part plus part, 20 plus 16. We have an entire base of the big triangle as 36. And now we can take that 36 and plop it right in for the base. Okay, so again, just to simplify our picture a little bit, we wanted to know the area of this whole triangle that has a height of 15 and a base of 36. And so plug it into the triangle formula for area, and we're looking at 1/2 times our base of 36 times our height of 15, and we end up with an area of, I'm almost out of room here, 270. And because these are measured in yards, we'll say yards, okay? But we're going to go ahead and say yards squared. Anytime we label area, it's in square units. And the reason is this 36 was in yards, this 15 is in yards, and yards times yards is yards squared. And that's where the label comes from. That's why area is always labeled in units squared, whatever your units is. Could be inches squared, centimeters squared, okay? All right, let's take a look at the next one. It says Kiara has a square poster that she is framing and placing on her wall. The poster has a diagonal of 58 centimeters. So this is just the poster. Okay, the rest of it's the frame that goes around the poster. Okay. It fits exactly inside the frame. The width of the frame around the picture is 4 centimeters. Okay. Determine and state the total area of the poster and frame to the nearest tenth of a square centimeter. Okay, and so what we have to realize and we need to do is we need to figure out the entire area of this picture. Okay, it is square, so that's cool. All right, and remember, squares are rectangles, and so we're going to use our formula: area equals, okay, base times height. Okay, it works for squares and rectangles because squares are rectangles. Okay, but we have a bit of a problem, right? We don't know our base, which would be this, and our height, which would be the same, which would be that. Okay, so as soon as we find one, we'll be fine, right? Because we'll plug in the same number. All right, so we got to figure out how to find this. So, well, I guess we're going to have to realize is that we got a nice right triangle in here. Okay, with a diagonal of 58, but we don't know these two dimensions, but we do know that they're the same. So if we call them both x, and we can go ahead and use our Pythagorean theorem and say that x squared plus x squared equals 58 squared, since 58 is our hypotenuse. Okay? X squared plus x squared is 2x squared equal to 58 squared, which is 3,364. We cannot square root yet because we got this 2 here, but we can divide by 2 so that x squared is now by itself, and we can square root in the next step. Okay? This gives us 1682. Go ahead and square root, and x comes out to equal 41, it's not perfect, 01219 dot, dot, dot. Okay? And so now we know this dimension here. Okay, except we have to realize that the frame is 4 inches longer on this side and 4 inches longer on that side. So we have to add 8 to this to get the dimension of the whole square. Okay, and so now we're going to figure out that our base here is no longer unknown, that our base is 49.01219 dot dot dot. Okay, and the same thing with our height. Okay. It's not gonna let me erase. Nope. There we go. Okay. Our height is the same, and so this is also 49.01219 dot dot dot. Okay. And so now we can go back to our area formula and say that the area of this poster and frame together is equal to my base, which is 49.01219 dot dot dot, use the full decimal, times the height, which is 49.01219 dot dot dot. Okay. Make sure you use the full decimal so we get an accurate area, and then the last step is to round, okay? And it comes out to be 2,402.195 dot dot dot. All right, and looking up, they wanted it to the nearest tenth of a square centimeter. So nearest tenth would be the 1. Look next door, the 9's going to change it. And so now we can finally say that our area is equal to 2,402.2 centimeters squared. Okay, again, it's area, so it's labeled in centimeters squared. Okay, all right, let's take a look at the next one. Number 3. It says that in the diagram below, the circumference of circle O is 16 pi. The length of BC is 3/4 the length of diameter AD, and CE is 4 inches. Calculate the area in square inches of the trapezoid. All right, so cool thing is we have a trapezoid formula for area. So we're going to write down area of our trapezoid is equal to our height times the average of our bases. So it's kind of like base times height, like it is for a rectangle, but because the bases aren't the same length, we have to average them first to get one single base length and then times it by the height. Okay, so we're going to go back to that one first piece of information they told us. They told us that the circumference of this circle is equal to 16 pi. If we go to our formula sheet, they tell us that circumference is equal to pi d. So if we replace that c, which stands for circumference, with the formula, which is pi d, we get this. Okay. If we want to solve for this d to know the diameter, all we have to do is divide by pi on both sides. And what happens is that we find out that the diameter is 16. Well, a diameter of a circle goes right through the center from edge to edge. And so we now know that AD is 16. Well, AD is the base or one of the bases of our trapezoid. And so we're going to go ahead and use a little replacements now that we know we have something. Okay. So we'll keep the structure of the formula in here, but I'm going to replace one of my bases, let's say base 1, with 16. Okay. All right, let's see what else they told us back up here. It says that BC, do you guys see BC? BC is actually my other base, and they're telling me that it's 3/4 the length of our diameter AD. Well, we just figured out that our diameter AD is 16. So we're going to set up a little math that says 3/4, which is 3/4, okay, or 0.75, times 16. And 3/4 of 16 is 12. And so now we know that BC is 12. And so now we can replace our second base with 12. Okay. And remember how they gave us CE being 4? That is our height. And so that can go in for our height of our trapezoid. And I think we used all the information in there. We have our formula for area filled in, and we're ready to go ahead and calculate. Okay, we got to clean that fraction up first. So we're going to go ahead and combine the top. All right, so that we get our trapezoid formula. Okay, so the 4 is going to stay. 16 plus 12. Okay, up on top here is 28, and 28 divided by 2 is 14. And so now we just have 4 times 14, and we end up with an area of 56. And we are in inches, and because it's area, would be inches squared. And this problem's finished. Okay, very good. I'll see you guys on the back side of notes.